because there are some people who will be visiting that playlist. So if you're told to evaluate the integral of cos cubed t dt, you use the Moivre's theorem to get rid of power 3, okay? So from the Moivre's theorem, when you have 2 cos n theta, that is Zn plus 1 over Zn, then if you have 2j sine n theta, it is the same as Zn minus 1 over Zn. Are we together? So from this you can see when you have 2 cos n theta to be Zn plus 1 over Zn, this means when n is equals to 1, then 2 cos theta is equals to Z plus 1 over Z, meaning where there is n, if you put 1, so you get 2 cos theta is equals to Z plus 1 over Z, isn't it? Then we also have here, when you have 2j sine theta, this is equals to Zn minus 1 over that is what you have. So from there, we now come and see, what do we want? We want cos t, meaning our theta is t, isn't it? Our theta is t. So if our theta is t, this is now cos nt, cos t, cos t. Our theta is now t in this case. Are we together? Our theta is t. So can you now come? What do we want? Cos cubed t. So you go where you have cos t. So we've seen there we have 2 cos t is equals to 2 cos t is equals to z plus 1 over z, isn't it? But we want cos t raised to power 3. If we want cos t raised to power 3, meaning we raise both sides of the equation to power 3. Are you seeing that? Because we've seen here 2 cos t is z plus 1 over z, because where there is n, when n is 1, we remain with cos t, z to power 1 plus z to power 1 which is z, z to power 1 which is z. So 2 cos t is z plus 1 over z. Are we together? But we don't want cos t, we want cos t raised to power 3, meaning we raise both sides of the equation to power 3, isn't it? Are we together? You raise both sides of the equation to power 3, then you come 2 raised to power 3 is 8. Cos t raised to power 3 is cos raised to power 3 t, to be equals to, on this side of the equation, that is binomial expansion, isn't it? So in binomial expansion, when the power is 3, it means you have 4 terms, isn't it? It means you have 4 terms. So here, the first term, plus the second term, plus the third term, plus the fourth term. Then what is the coefficients of power 3? 1, 3, 3, and 1. Those are the binomial coefficients of power 3, isn't it? Then the first term inside this binomial expansion is z, isn't it? So we have z, 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 z. Are we together? Then the second term in this binomial expansion is plus 1 over z. Plus 1 over z is just 1 over z, isn't it? So 1 over z, 1 over z, 1 over z, 1 over z. Are we together? Is that okay? Then from there you put the powers. 1 power ascends and 1 power descends. So for you to ensure that you have a form z plus, and z minus, meaning you must start with z. So you make this 1 over z to be ascending, to start with power 0, isn't it? Because anything raised to power 0 is 1. So the reason why you ensure this one ascends is so that you don't go back to start from the other end. You just move forward ever, isn't it? But whether you start with power 0, you still get the same answer. But now this one gives you forward ever, backward never, isn't it? Are we together there? Yes. So power 0, power 1, power 2, power. Then the other one descends. Power 3, power 2, power 1, power. Then you know anything raised to power 0 is what? Is 1. This is 1. This one is also 1, isn't it? Now you join them. This side we have 8 cos cubed t. Then this side, the ones with the same coefficients will always have the same power. Are we together? This is having a coefficient of 1. This one is also having a coefficient of 1, meaning when you work them out, they will have the same power. Are we together? So z raised to power 3, it means you factorize 1 outside. Here you remain with z raised to power 3. Then here you remain with 1 over z cube is 1 over z cube, isn't it? Are we together? So it is plus 1 over z cube. So you join the ones with the same coefficient 1 together. Because here you have z cube, there you have 1 over z cube. Because 1 cube is just 1, isn't it? Are we together? Then this other one, coefficient of plus 3, coefficient of positive 3, isn't it? So if you put that same coefficient, you join here, you have z squared divided by z is z. So when you get it to be z, you don't even need to struggle with working out this, meaning this one must also be 1 over z, isn't it? Are we together? So what you need to know is whether the sign is negative or positive, isn't it? Are we together? But here all the signs are positive, so definitely it is positive. Is that okay? So it is plus 1 over z. You've now joined this, you've joined the toe with coefficient of 3. Z squared divided by z is z, isn't it? Are we together? Then z divided by z squared, because 1 over z squared is 1 over z squared, isn't it? So it is z over z squared, you get 1 over z. Are we together? Then you go back. What is z cube plus 1 over z cube? It means n is 3, isn't it? So when n is 3, when you put 3 where n is, z cube plus 1 over z cube. When you put 3 where n is, you get 2 cos 3t. Meaning the whole of this is the same as 2 cos 3t. Are you seeing that? Then you move to the other one, z is power 1. When z is power 1, you go to the one with addition. The one with addition is the cosine, isn't it? So when n is 1, where there is n, you put 1. Meaning this is the same as 2 cos t. Meaning the whole of this is the same as 2 cos t. Then what do you want? You want cos cubed t. So if you want cos cubed t, you remove the coefficient, isn't it? Meaning you divide all through, you divide both sides of the equation by 8. So if you divide both sides of the equation by 8, you've now ended up finding that cos cubed t is just 1 times 2 is 2. 2 divided by 8 is 1 over 4 cos 3t. Then 3 times 2 is 6 divided by 8, you get 3 over 4 cos t. So you see, cos cubed t can be expressed in this form using the Moivre's theorem. So it means you use the Moivre's theorem to get rid of the power for you to be able to integrate that cosine function. Is that okay? Are we together? So you come back to your integration. You come back to your integration, you found this is the same as where there is cos cubed t, you put the value of cos cubed t, which is the same as 1 over 4 cos 3t plus 3 over 4 cos t dt. Are you seeing that? So you found the value of cos cubed t is the same as this using the Moivre's theorem, isn't it? Are we together? Are we together? So you've now gotten rid of the power, so you can integrate. You can now see the inner function is the derivative of the inner function a constant. So start integrating. A quarter is a constant. If you integrate cos, you get positive sign, isn't it? So if you integrate cos 3t, you get sine 3t. Then you divide by the derivative of the inner function, which is 3. Are we together? Then you move plus, here the constant is 3 over 4. If you integrate cos, you get positive sign, isn't it? So you get sine t, then you divide by the derivative of the inner function, which is, must be a constant, isn't it? Then at the end of the integration process of an indefinite integral, you add the arbitrary integration constant, isn't it? So from there you can only simplify and you are done with the entire integration process. 1 over 4 divided by 3, you get 1 over 12 sine 3t, then plus 3 over 4 divided by 1 is just 3 over 4 sine t plus c. So if you have the limits of integration, then you do away with the arbitrary integration constant and you put the limits of integration provided, isn't it?